Okay, we're back with Newton's third law. And this meme, this picture, really illustrates to me what I think of with Newton's third law. I think of those in Soviet Russia jokes that you may have heard. So in Soviet Russia, bounce house, bounce on you. So this is the one that I like to call Newton's law of Soviet Russia jokes. If that helps you remember, great. If it doesn't, forget about it. So, Newton's third law states that for every force, there's an equal magnitude and opposite direction reaction force. Any interaction involves two forces that we call action reaction pairs. So, example, you hit a ball with a baseball bat, the ball hits the bat back. A runner's feet push against the ground pushes back on their feet. A fish's fins push on the water pushes on the fins. So we only really get these reactions if we have action-reaction force pairs. So that baseball bat is hitting the ball, and because it's making contact with the ball is making contact with the baseball bat. A fish pushing on the water isn't going to move unless the water pushes back. So imagine, if you will, a bug and a truck windshield have an interaction. We'll politely call it an interaction. So we've got this juicy June bug that splats against the window of a truck. What force pairs are going to occur here? Which force is bigger, and which object has a greater acceleration? So think about it for just a moment. Pause the video. Okay, so what force pairs occur here? So we've got our little bug, and we have our big truck. So the truck exerts a force on the bug. I'll call this Ft for F truck. And the bug exerts a force on the truck. So we'll call this Fb for F bug. Okay, which force is bigger? So because of Newton's third law, we have these action-reaction pairs. These two forces, even though these objects have completely different masses and velocities, these two forces are the same. They are the same. This is a super important concept. Ft equals Fb. Okay? That truck is hitting the bug with the same force that the bug hits the truck with. So what's different between the two of them? You're thinking, like, one of these is much more massive. The truck is huge and the bug is so tiny. So why do they have the same force? Well, they have the same force, but their masses are different and their accelerations are different. So mass is not the same. M bug does not equal M truck. Their accelerations are also not going to be the same. A bug does not equal A truck. Okay? So our accelerations are going to be different in this situation because our masses are different. And if you look at the equation, F equals M times A, remember, M and A have an inversely proportional relationship. So you should be able to think through which object is going to accelerate quicker. So take a moment, think about which object is going to accelerate more than the other. Okay, because our truck has more mass and these two have an inversely proportional relationship, our acceleration for the truck, because of this interaction, is going to be less. So that bug is not going to make that truck accelerate very much at all. But because our bug is so small, our bug has a tiny mass, that means our acceleration for the bug is going to be much greater. So the object with the greater acceleration is going to be the bug. Okay. So again, truck hits bug, bug hits truck. Neither force is bigger because of Newton's third law, and the bug is going to have a greater acceleration because m bug is much less than m truck. So here's some more examples of force pairs. A person is doing some sort of martial arts, and they hit a brick with their hand. So person hits brick, brick hits person. Another big example is a rocket. So a rocket is pushing exhaust gases downward. So out of this rocket here from the space shuttle, we've got all of these hot gases being pushed downward onto the Earth. So the gases are pushing downward, and that means that the gases are pushing the rocket up. So the rocket is pushing the gases downward, and the gases are pushing the rocket up. And yes, the gases are pushing on the Earth, and the Earth is pushing back on the gases, but that's not the only mechanism for how a rocket works, because we have rockets that work in space, and they're not really pushing against anything. It's space, man. There's not much out there. I mean, there's a lot out there, but there's a lot of space between stuff. So the real reason that rockets work is, again, because they're pushing those exhaust gases down or out, and the gases are pushing back on the rocket, which is why we have these huge rocket fuel tanks for our rockets and for our payloads. It's because we have to have a lot of gas. We have to have a lot of mass to push something that's big and heavy back. Okay? So you need a lot of mass being pushed out to create an acceleration on the other end. It means we need more mass coming out than we have supported inside of the rocket. So rockets can be kind of a tricky thing to get to work, just because you have to have the right amount of mass to create the right amount of acceleration, the right amount of force and acceleration. All right, ignore this homework, my online students. We are going to do some other practice stuff, but I highly recommend that if you haven't read the chapter yet, please read page 88, Problem Solving for Newton's Laws. This will help you a great deal with future problems, and I do recommend this practice. I may assign it later, but I recommend trying out this practice if you would like. All right, that's all I have for Newton's laws. Next video will be on free body diagrams.